Hello everyone. In this video, we'll see how to emulate the I3C traffic using the UI window or the scripting window that the Prodigy I3C exerciser and protocol analyzer graphical user interface has. Before doing the emulation, the user need to configure the controller and target to the I3C network. Now, how to exactly do this? We have already covered this topic in one of our previous video, that is configuring the controller and target to the network. You can check it out if you want to know how exactly this is done. Now coming to the emulation. Once you have configured the controller and target, how to do the traffic emulation using the UI window or the exerciser window. The Prodigy I3C exerciser and protocol analyzer has two flexible methods for traffic emulation. First one is the UI based window for manual transaction framing, and the other one is the scripting window for much more advanced traffic emulation. First, let's start with the UI based controller window. In this mode, the traffic generation is fully parameter driven. Bus and timing parameters are configured by entering their value in the respective tabs. And once the commands are framed, the user can send the command from the summary so that the controller will emulate that traffic, and that will be analyzed and decoded immediately using the analyzer mode in the I3C exerciser and protocol analyzer. Now let's take an example. Let us try sending the broadcast command reset DA, which is nothing but resetting any previously assigned dynamic address to the targets in the network. For that, initially, we need to configure the timing parameters. The sys parameter or the sys keyword is nothing but used for configuring the push-pull frequency along with the duty cycle. So let's configure the push-pull frequency as 500 kHz along with the high period and low period, and we have an option of inter-message gap. This option is to give gap between the frames that the user is sending in repeated scenarios or different scenarios. So if the user is sending 2 or 3 frames and they want to have a delay between each of these frames or each of these commands, the user can use the inter-message gap, and this value can be given in second, millisecond, microsecond as well as nanosecond. And clock to data delay also is another configurable timing parameter from the Prodigy side. So the user can configure the clock to data delay value by again giving it as a preference of their choice. Once you have framed one timing parameter configuration, the user can give it an add, so that that particular timing configuration will be configured into the summary list. Now let's go for configuring the open range frequency. Let's keep the open range frequency also to 500 kHz along with the duty cycle and the clock after start value as 2 microseconds. Once again this is done, the user can give an add so that it will again get configured in the summary list. Next is the sys extended timing parameter configuration. So this is again the keyword used for configuring the setup time and hold time. So let's keep the setup time for start as 20 and the setup time for stop as 50. And all other timing parameters the user can configure upon flexibility, like they can configure according to their testing scenario. It is not mandatory for configuring every single timing parameter. Now all the timing parameters are configured in the summary list. Let's go for framing the I3C common command code reset DA. So for that, again bus is the frame or bus is the keyword parameter that is used, and the user can choose the message type as broadcast, directed, private or I2C message. So now we are going to send a broadcast reset DA command. So I am selecting the message type as broadcast. And once you have selected the message type, the user can see all the broadcast common command codes listed out as per the I3C specification. So now let's choose reset DA from this drop down. And after that, there is an option of stop. So if the user want to have a repeated start or a stop after the emulation of this particular command, the user has the flexibility to choose by just checking in that box. If the user checks in the box, then the stop will be issued by the controller after sending this command. If not, it will be considered in as a repeated start scenario. And the user can also go for injecting errors into the frames by selecting the command parity or data parity check-in box available here. So once the bus command is selected, the user can give an add. So that in the summary list now the user can see the timing parameters are configured along with the I3C command that which we are going to send now. Once the commands and timing configurations are done, the user can give a start or stop capture so that the analyzer will continuously capture whatever activity that is happening in the bus. Once the user has selected the start and stop capture, the user can now run this command. You can see once you have hit the run, immediately the analyzer will track down the activity that has occurred on the bus, and you can see the reset DA command was issued along with the address start, address write, act, the command code and the stop from the controller. So once the user has sent the command, it will be immediately decoded and it will be displayed along with the command details in the selected frame view and the digital representation in the plot view. This is how the user can emulate the I3C or I2C traffic using the UI window. Now let's switch to the scripting window. In the scripting window, the parameter configuration is exactly similar to the UI based system, but here the user have the flexibility to load preloaded commands for major I3C commands or I2C commands. So the user can load the preloaded sample scripts and edit the sample scripts as per their testing scenarios and later save it as a new sample script or save it in the existing sample script also. One of the main key advantage of this scripting environment is its context sensitive assistance. As the commands are typed, the tool automatically suggests the valid keywords and syntax, and that gives an idea to the user how to frame the script as per their required scenario. So the user can choose what kind of frame exactly they want. If they want to go for framing any I2C or I3C commands, they can choose the bus keyword and then give a space. It will again give you suggestion. If it is a frame, what exact type of frame the user is looking for. Is it a broadcast direct, or is it like a hot join, I2C, IBA response? So from the drop down, the user can again choose what type of frame they are planning to emulate. So let's choose one broadcast command, and once you again give the space, you will be again provided with the drop downs of all the broadcast command that is listed out as per the NIPI I3C specification. The timing parameter configuration is exactly similar here to the UI window configuration. sysOD is again the keyword parameter for configuring the open range frequency along with the duty cycles, and sys is the keyword for configuring the push-pull frequency along with the duty cycle, and TCO is the clock to data delay, and sys extended is the keyword parameter for setting up the setup and hold time. So all these parameter values by default will be given in the preloaded script, but again the user can edit all these parameter values as per their testing scenario also. Once the user has framed the script in the scripting window, again the execution is exactly similar to what we are doing in the UI window. The user just need to give a run, and you can see immediately those frames are emulated and it is decoded along with the plot view. So this is how the scripting is done using the scripting window, either for the controller or the target. The scripting language again used here is an in-house proprietary language that is developed by the Prodigy that is specifically optimized for protocol validation and traffic generation. So this provides much more streamlined and effective experience tailored for I3C or I2C traffic emulation. So in summary, the UI-based window enables precise parameter-driven transaction framing with manual execution, while the scripting window offers much more flexible and scalable traffic generation for advanced validation scenarios. Thank you, everyone.